Let's take a look at the draft analysis tool found inside of Alias. I'm working on a team right now, and a couple of us, even though we've had years of experience, are using this tool slightly differently and we're getting different results. So let's have a look at some best practices for this tool. Here, I've just created basically a sphere, but I'm using the draft tool in order to set an exact angle and create the dome portion of this. 15 degrees, 30, and 45. The first thing, let's hide our vectors, is we want to decide what direction we want to evaluate. Often this is determined by the dipole direction. So the dipole direction in this case is going to be in Z. It's very important to determine whether Z is positive or negative. Inside of the tool, if we just activate the draft analysis tool, I can set this quickly to X, Y, and Z. But notice the Z only gives us a positive value. So if we want to evaluate accurately the bottom side of this sphere, then I'll have to make this a negative. Now, there is an interactive method to do this with a manipulator. So I can click on all of these axes or change the angle here. And let's say from the top, we're going to evaluate it. But watch what happens when we retain the vector. So I'm just going to click here. It's going to create the vector it's using. Notice the vector is pointing away from the object. And this is very important. When we build our own custom vectors, we want to have the same orientation. So let's go ahead and delete that, and I'll bring our vectors up. So when I create a vector, I always want the vectors to point away from the object. If I select the vector on the top, and I'll hit update from selection, it will use that one. And if I select the vector from the bottom and hit update selection, then it will use that one. Notice the blue and the red flipped. And now the positive draft angles are being evaluated on the lower side. Now we can show the negative ones, which are highlighted here in green, but I believe that the best way to use this tool for most cases is just to evaluate the positive side, and that way you only have the two colored options to choose from or to evaluate. Now, let's switch this over to the top. So it's in Z, positive. And if I set this to 15 degrees, you can see that that first band highlights kind of in this blue and red pattern. Very strange that Alias does this, but what that means is that that surface is exactly 15 degrees. Now on a surface that has a lot of shape, this is going to be a single line as opposed to a plane. If I evaluate this from 16 degrees, which is was larger than the 15, then that first band is going to highlight red, and we'll get a very clear mark between the 30 degree and the 50 degree portion. Let's take a look on a real part. I have a panel that could be a glove box or down by the knee blocker area of an IP, and we want 3 degrees of draft along all of the edges. Now, often with these types of panels, instead of pulling in an exact dipole direction or a X, Y, and Z direction, it will be specified X and then a degree number. I create this little curve setup with a vector on it in order to have an element in the scene that I can always go back to evaluate this part, or importantly, to share with engineering or share with other people to make sure that we all are using the exact setup. Curves will go into other applications where the vectors from Alias may not. So to create this, what I do is I'll go into a view, and if it was specified in X, I'm just going to drag it, straight line, I'll copy, paste, same layer, and I'm going to use the information window to specify an angle, and let's just say 20 degrees. And then what you can also do is, let's say in Z, we'll have 5. And so this is slightly, it's bent down 20 degrees and then rotated also in 5 degrees. Then I'll create a vector, and I'll just snap it here. And we'll go ahead and scale that, make it a little larger. And now, if at any point in the project something changes on our dipole I just come to the curve. I can retype in, say, 0, and the vector is going to update. Once I have that this part created, which I've already done earlier in the oven, now when I evaluate this piece, 1 second, something seems very strange on this part. Do you see this pattern where it looks like checkers? The normal tool uses the visual orientation of the surface. So before we move forward, I want to go to Surface Edit, whoops, there we go, Surface Edit, Orientation, Set Visual Orientation, and I want to make sure everything is pointing in the same direction. So in this case, I'm just going to bounding box with my left mouse button to make sure everything is highlighting in blue and the inside is all yellow. Now when I go back to the tool, we don't see the checkered pattern that showed that some of those surfaces were flipped around. We want to use this vector, so I'm going to select it and say Update from Selection. Since we know we want 3 degrees of draft, or at least it has to pass a 3-degree draft test, I'm going to select 3. And you can see now, from this angle, all of our flanges down here along the bottom side are nice and blue. And then along the top, we have this area, which shows that noise of, it is exactly 3 degrees of draft. It's a flat plane. And then we have this little piece here, which is actually just a flat spot on the top of this panel, which would become our part line. That's where the two parts of our mold will come together. So that part is okay to be read because we want that on the opposite side, the other part of our mold. I think that's a good example to see the draft analysis tool, and the most important part is to create the vectors pointing away from your object in the direction of the dipole. Thanks a lot. We'll see you guys next time. Peace. Keep surfing, everyone.